When this video is about resolving forces, resultant force, and equilibrium. Prerequisite knowledge, something you have to know in previous classes. We have SOHCAHTOA here. We have angle theta, this is the opposite side, the adjacent side hypotenuse, and we have the definition of sine, cos, tangent, and we have a transversal two lines parallel cut with by another line, and we have, let's say this angle is theta. This is a straight line, so this must be 180 minus theta, and we call this vertically opposite angles, and this theta with this theta are corresponding angles. Now, resolving forces or splitting into components. Choose the set of axes, draw a right angle triangle, identify angles, and use trigonometry. So for example, we need to split this 10 Newton force vertically and horizontally. Just draw a triangle. This is 30 degrees, the angle is 30 degrees, the hypotenuse is 10. Just label this height of the triangle y, the base x, and from the definition of sine opposite over hypotenuse, we get, after multiplying by 10, we get y equals 10 sine 30 degrees, which is 5 if you use a calculator. So the y is 5, so that's why we have this 5 newtons. And from the definition of cosine adjacent over hypotenuse, multiply both sides by 10, we get x equals 10 cos 30 degrees, which is 5 root 3. So this means this green 10 newtons force can be split into this and this, 5 root 3 and 5. Same thing with the 12 newton force here. We have the triangle, label the angle and the hypotenuse, and call the side x and y, and from the definition of sine, which is opposite over hypotenuse, we get the y. Using a calculator, we get 6 root 2. Same thing with the cos, so we can split this into 6 root 2, 6 root 2. Finding resultant force, split into components, find the resultant of each component, and use Pythagoras. So for example, the 10 newtons force, 30 degrees to horizontal, 14 newtons, 60 degrees to vertical, 7 newtons, 45 degrees to horizontal. We can split this green force into 5 root 3 and 5, because this is actually 10 cos 30 degrees, and this 5 is from 10 sine 30 degrees. And for the green force, you can split into this component, the cos, so this is 14 cos 60, which is 7, and this component to the left, which is 14, the same as this line here, so this, it's the opposite of the 60, sine 14 sine 60 is 7 root 3. You can split the 7 newtons to 7 root 2 over 2. And for the resultant now, 7 plus 5 is 12. We still have 7 root 2 over 2. We still have 5 root 3, and here we add 7 root 3 and 7 root 2 over 2. And for the total in y direction, we have the 12 is actually bigger than 7 root 2 over 2, so this is 12 minus 7 root 2 over 2 upwards. And when we subtract this longer force to the left and this shorter force to the right, we subtract 7 root 3 minus 5 root 3 is 2 root 3, so we have 2 root 3 plus 7 root 2 over 2. This is the hypotenuse using Pythagoras. And you can also find the angle actually using inverse tangent, opposite over adjacent. Inclined plane. So when we have something, an object on an inclined plane with some slope, angle alpha, first of all, we always have a weight force vertically downwards. Now, if you draw like a right angle triangle here, you extend this line of action 90 degrees. Of course, this must be 90 minus alpha, and this is also 90 minus alpha because it's corresponding angle, and this is also alpha because the total here is 90 degrees. So this is alpha. And now if you look at this triangle here, I'm drawing the triangle here again. This is alpha, and this is the hypotenuse W, and name is this A and B. Cos alpha is adjacent over hypotenuse, which means the A is W cos, so this component is W cos. That's why this component is W cos, and this component is B, which is W sine. So this line here is W sine, which is the same as this. So that's why we have W sine and W cos. Or just find a way to memorize it. We use sine for the parallel and cos for the perpendicular to the slope. Forces acting at a point, so we have for root 3 downwards 120 degrees F1, 150 degrees F2. If we need to find F1 and F2, here we can split the F2. Look at this 30 degrees. If we use this dotted triangle, this must be the cos. This component is using sine, and we can split the F1 also. If you look at the triangle, this is the cos, this is the sine. Now we have in equilibrium means the total force to the left and right are the sigma f x equals 0, sigma f y equals 0. The forces, horizontal forces are the same, or the resultant is 0. The force to the left must be equal to the force to the right. So sine 30 is 1/2, sine 60 is root 3 over 2. So we have f2 equals 6. You can find the, okay, actually we have f2 equals root 3 f1, and from the total force upwards, which is f2 cos 30, so this component of f2 and this component of f1 cos 60 must be equal to the total force downwards, which is 4 root 3. So this is total force upwards, total force downwards, total force to the left, total force to the right. We have two equations in two variables. If there's a solution, we can find it by substitution or elimination. So here we substitute f2. So we have f2, we substitute with root 3 f1, and we simplify. Root 3 times root 3 over 2 is 3 over 2, plus 1 over 2, 4 over 2, which is 2. So we can find the f1, plug in back here, we get the f2. Alright, that's it. I'll see you again next time.